Okay, so now we want to look at OSPF external routing. External routing is used to enable your autonomous system to be able to communicate with other ASs, with other autonomous systems. So that is exactly what you're going to learn here. Please mute your mic if you do not want to make a contribution. So, just as a reminder, so far we've looked at inter-area routing, and when you talked of inter-area, we looked at several LSAs. That is the router LSA and the network LSA. So we said this is called type 1 LSA, and we've also looked at this one here, which is called type 2 LSA. We also said that this one is type 1 LSA is actually generated or produced by each router for each area it is connected to. Then you have the network LSA, type 2 LSA. It is produced by the DR. So this is actually within an area. Now for inter-area LSA, it uses the type 3 LSA. The type 3 LSA is also referred to as the network summary. Right? Is that correct? Network summary is also known as the type 3 LSA. And the network summary is originated by which router? Someone? Can I be heard? Are you able to hear me? Hello?
Yeah, I can hear you.
Okay. So at this particular point, we want to see external routing, LSAs. So we have two types of LSAs that enable us to do external routing. So one of them is what we call the ASBR summary LSA. So this is type 4. So we're going to understand what that is and how it's generated and which router generates it. And we're also going to see another one called the AS external LSA. This is what we call the type 5 LSA, link state advertisement. So we're going to understand them. By the end of this chapter, we should be able to know how they operate. Okay, so let's move on. So in addition to internal communication, enterprises require communication with external networks. So suppose the OSPF protocol has been deployed in company A's enterprise network to enable internal communication. When there is a need to visit the web server situated on the enterprise network of company B. So as a network engineer of company A, how could you import routing information from company B's enterprise network in order to accomplish your goal? So this is the scenario that we are going to use to learn about OSPF external routes. So by the end of this chapter, you should be able to, number one, have a volunteer. Okay, so I'll read. Number one, understand the functions of AS external LSAs and ASBR summary LSAs. Be familiar with the calculation method of OSPF external routes, and also be able to understand the cause of suboptimal external routes. Let's begin by looking at external routes. So generally, here we have two autonomous systems. So let me just undo that. So we have these routers that belong to company A. So those routers belong to company A, and we have another autonomous system here that belong to company B. So we want people in our network, people in company A, we want them to be able to access this server on company B network. So how do we go about that? How do we go about that? Now, the very first thing you have to do is to ensure that RTA, which actually connects to the router on company B, can be able to reach that server. So for that particular purpose, in this scenario, we've configured a static route. So we've configured a static route from RTA to this particular network here. So that network is where that server resides. So the command IP route static, then the network address, then the next thing that follows is the mask, then the next hop. So if you want to go to this network, you need to send that packet to this interface. So that's the next hop. Now, after we have reachability between RTA and company's B network, now in our OSPF, we can go into our OSPF. Remember, within our autonomous system, within company's A's network, we are running OSPF 1. So we can use the command import route static. Import route static. So what that will do is that this particular command will advertise that particular static route in our autonomous system. So RTA is simply going to advertise that route to RTB and RTC. Then RTB and RTC are also going to advertise it in the other areas that they are connected to, like that. So everyone will know how to go to this network. So that is what we call an external route, because it's outside our autonomous system. Okay, so let me explain what we call the type 5 and type 4 LSAs. Now, this router here, this router here that imports external routes into our autonomous system is called an ASBR. That router is called an ASBR, meaning autonomous system. Wait for that. So while an ABR is called a area border router, ASBR is boundary. B there is for boundary. So autonomous system boundary router. So router A is an autonomous system boundary router. Now, when it imports an external route into area 0, it actually imports that particular route as a type 5 LSA. Now, what is a type 5 LSA? What is a type 5 LSA? So a type 5 LSA is what we call the AS external LSA. AS external LSA. What is the purpose of an AS external LSA? This particular LSA, so here, what we are saying, let me see if I can expand this. So here what we are saying is the router that generates a type 5 LSA is the ASBR, Autonomous Boundary Router. So what is a type 5 LSA? Type 5 LSA is used to describe a route to a destination external to the autonomous system. So describe a route to a destination external to the autonomous system. Please mute your mic. Someone is disrupting the class. Okay. So that is what we call a type 5 LSA. So RTA will advertise type 5 LSAs. So a type 5 LSA originates from an ASBR and is used to describe a route, not router. Is used to describe a route to a destination that is outside the autonomous system. Now, when an ABR receives a type 5 LSA, like here, RTB has received a type 5 LSA, and also RTC has received a type 5 LSA. What they do is that they forward the type 5 LSA to the other area which they are connected to, but they also generate what we call a type 4 LSA. So you can see here, so it will forward, the area border router will forward the type 5, but also create a new type of LSA, which is known as the type 4 LSA. So what is a type 4 LSA and what is it used for? So type 4 LSA, as we've seen, is actually generated by an ABR, area border router. Now, a type 4 LSA is used to describe routes from themselves to the ASBR. That is really, let me just use ABR here. Routes from the ABR to the ASBR. So a type 4 is simply used to tell, for example, RTD here that, hey, if you want to go to the ASBR, you have to pass through me. You have to forward that packet to me. Then I'm going to help you to forward it to the ASBR. So that is what we call the type 4 link state advertisement. So an ABR will generate a type 4 from a type 5 LSA. So I hope that is clear. Okay. So let's go on to the next one. So this is how the type 5 LSA looks like. AS external. Okay, so remember here we are using this topology. So we are in this network, we are in this router RTA. So we want to see the type 5 LSA that it actually produces, how it looks like. So that's the example that we are using here. So if we are in RTA and we use the command display OSPF LSDB, so ASE, autonomous system external, self-originate, meaning RTA is the one that has generated that particular external route. So we can see that this is on OSPF process 1 with the route ID 1.1.1.1. Then we can see a few details here. So I can explain, for example, the type. We see that it's a type 5 external. Then we have the LSID. The LSID here is the network address of the destination network segment, the external network address. Let me just go back so that you understand that. So 60.0. So that is the network address of the external network that you are importing. So whatever you're importing, so that is what you get on that field. Then after that we have the advertising router. So the advertising router is the router ID of the autonomous system boundary router that generates that particular type 5 LSA. Link state age, you know what that means up to there. Then we have the network mask. So the network mask is the subnet mask of this network, this external network. Then we have the metric. The metric is the cost from the cost of the route from the ASBR to the destination network. The default value is normally 1. The default value is normally 1. Then watch this guy here. This guy is called the forwarding address. Right now it's 0.0.0.0. In the coming slide, we are going to see how that can be used. Then we have what we call the tag. The default value is 1, and it's used especially for the purpose of what we call routing policy. So later on, we are going to learn about routing policies, and you might see how that can change. Okay, so let's move on. So now, the ASBR summary LSA. So now type 4. Now remember we said a type 4 is generated by the ABR. So in this particular instance, a type 4 will be generated by RTB and also RTC and injected to area 1 and area 2 respectively. So if we are in RTB, and we use the command, display OSPF LSDB ASBR self-originate, display OSPF LSDB ASBR. So this simply means it is type 4, self-originate, meaning you're the one that has created that type 4. So you're going to see that you've created it so that you can inject it to area 1. So you can see the type here is summary ASBR. You can see the link state ID here is used to describe the router ID of the ASBR. Then the advertising router is used to describe the router ID of the ABR that has generated that type 4 LSA. So the other ones remains the same with many others that we've seen. Then for the metric, this is the cost of the route from the ABR to the ASBR. Cost of the route from the ABR to the ASBR. So you can take a moment to just synthesize what I've just said there. Now, type 4 LSAs can only be flooded into a single area. It can only be flooded into a single area. So a type 4 cannot be forwarded to another area. Let me explain that because it's important. Okay, so we've said that at type 5, when it comes to the ABR will forward the type 5 LSA and also forward a type 4 LSA to this area. Now, in case we had another, sorry, what's happening? In case we had another area here, for example, we have another area and we have a router. Now, this router will receive the type 5 LSA and also the type 4 LSA. So it's going to use this type 5 LSA to create a type 4 LSA for this router. But it's not going to forward this type 4 LSA beyond area 1. So it's not going to use that type 4 LSA. It's going to create a new type 4 LSA so that now it forwards a type 5 LSA here and also the new type 4 LSA. So I hope that is clear, that a type 4 LSA cannot be forwarded beyond the area from which it was created or originated. Okay. So let's look at how we calculate external routes. Again, here you need to have the picture. You have to have the picture of the. You have to have the picture of that topology in mind. So RTA is connected to RTB and RTC within the same area, area 0. So how does a route to this network here, 60.0, how is it calculated? How is the cost calculated really? Okay. So what happens? So because they are directly connected and they're within the same area, how RTB, when it receives the type 5, how is it going to know that that the ASBR belongs to this area? It's gonna know that by examining the advertising router field from that type 5. So it's going to know that, hey, I'm in the same area with the ASBR. So once it knows that, then it's gonna set the next hop to this network as the ASBR. Similarly, RTC is also going to set the next hop to this network, so as the ASBR, because they are in the same area with the ASBR. So the next hop is going to be the interface of the ASBR that they are connected to. So that is what happens when they reside in the same area. What if you do not reside on the same area with the ASBR? How can you forward a packet to that external network? So RTB, RTD, let's go back to the we go back to this. So RTB and RTD. So we can see RTD is not connected to the ASBR because RTA is our ASBR, but it's connected to the area border router RTB. So if RTA wants to forward a packet here to that network, what happens? What happens? So that is what we want to know. So if RTD wants to forward a packet to that external network, it's gonna check from the type 4 LSA to know where the area border router resides. And if it wants to forward to this guy, it only needs to forward that packet to the area border router. And then the area border router will deliver it to the ASBR, and the ASBR will forward it to the external network. So the cost here is also 1, which is similar to the cost here, even though we can see that RTD is connected further away from the ASBR compared to RTB. So do you think this is correct? Do you think this is correct?
Yes.
Let me just explain that further. You see, we are saying the cost from RTD to the external network, this one, which is connected to RTF, is the same as the cost from RTB. So both of them have a cost of 1. That's what I'm asking. Do you think that is correct?
Yes. I think it should be correct because of the imported routes.
Okay. So generally, when it comes to cost, we normally add the cost of the interfaces of the outgoing outgoing interfaces. So you see, for example, if the cost is 1 here, 1 here, 1 here, if you're coming from RTD to the external network, the cost should be 3. But if you're coming from RTB to the external network, the cost should be 1 maybe, or 2. You see, this one should be a little should be longer than the other one. Anyway, so let me explain. Let me explain why both of them have the same cost. So OSPF external routes, we have two types of OSPF external routes that you must understand. The first one is called type 1 external routes, sorry. And the second one is called type 2 external routes. The difference is type 1 external routes considers the distance within the autonomous system, and also the distance from the ASBR to the external network. So it adds both of them. It adds both of them for type 1. But for type 2, it only considers the autonomous system external cost. I don't know whether you understood me. So let me can I, is it possible? Let me go back so that I explain better from the good. So what we're saying here is this, for type 1, it's gonna take this cost plus this cost. So we are sending a packet from RTD to the external network. So it's gonna add this plus this plus this to get to that one. So that is type 1. What we're calling the internal distance is this internal within your autonomous system. So like 1, 2. So within your autonomous system, before we get to the ASBR, the distance is 2, for example. Then to the external, again, the distance is 2. So when we are considering both the internal cost and the external cost, that is what we call type 1 external cost. On the other hand, if we are not considering the internal cost, we are only considering the external cost, then we call that type 2 external cost. So between type 1 and type 2, which one do you think gives a more reliable cost? Which one do you think is more truthful, if I can ask something like that? From the explanation I've given, between type 1 external cost and type 2 external cost, which one do you think is more accurate? Sorry, I think more than one person has. Okay, so someone has typed type 1. Good. So that is correct. So type 1 is actually more accurate compared to type 2 external costs. But the reason as to why in the previous slide the cost was 1 for both of them is because OSPF uses type 2 external route by default. So it does not cater for the distance within the autonomous system. It only caters for the distance outside the autonomous system. That is the cost between the ASBR and the external network. Please mute your mic. So I hope that is clear. So let's look at cause of suboptimal external routes. Now, sometimes you might have a network like this one here, and you're using multiple protocols. So for example here, between RTB and RTC, we are using RIP. We are using RIP. But also between, let me clear that. But also between RTB and RTA, we are also using another protocol, OSPF. So look here. Now, how will RTA learn about RTC's network? This network that has been attached on RTC. How will RTA know about it? It can only learn about it through RTB. Because RTB already knows about that network because they're exchanging routes with RTC using RIP. So RTB will know about this network. It will have it in its routing table. Now, if we configure RTB to import routes that have been learned via RIP into OSPF, then RTB is going to advertise that network as a type 5 LSA into the OSPF domain. And that is how RTA will know about this network. Now, when that happens, as we've already seen in the previous slide, when RTB advertises that type 5 LSA into RTA, RTA will know if I want to go to this network, then I have to forward it to the ASBR. So it will have to forward it to this guy. Actually, in RTA, if you do display IP routing table and that network address, you can see that the next hop is the interface on RTB. So that interface on RTB is the next hop. So it will forward it to RTB, who is the ASBR within that OSPF domain. Then RTB will forward it to RTC, and RTC will deliver it to that network segment which it's connected to. But if I clear the lines, you can see that that is not an optimal route because all the three routers have been connected on the same network segment. So if RTA wants to send a packet to this guy, the most optimal route is simply to send that packet to RTC via that interface. So this route is suboptimal. It's long, but this one is optimal. But OSPF, how does it deal with this problem? How does it deal with this problem? Okay, so what happens is that RTB, when RTB generates the type 5 LSA, when it generates the type 5 LSA, it's going to be aware that RTA and RTC are on the same network segment. Oh, sorry, I didn't. It's going to be aware that they're on the same routing segment because RTB already knows. Sorry, RTB already knows about this network segment that is connecting to RTC, and it also knows about this. So it knows that RTA and RTC are on the same network segment, 10.1.123.0. So once it knows that, when it generates the type 5 LSA, it will inform RTA using the forwarding address field on the type 5 LSA, which is normally 0.0.0, as we saw in the previous slide. So it will inform RTA that if you need to go to this network, RTA, if you want to go to this network, then use this address as the next hop. So that is what the forwarding address is used for, to specify the next hop so that we can avoid suboptimal routes. And therefore, after that, if you actually display the routing table for that particular network, you can see that the next hop now has been changed to the optimal route and to the interface on RTC.3. So ladies and gentlemen, that is it about this topic. So I now invite you to ask any questions if you have any. Then we can also discuss these 3 questions. Anyone with a question? Okay, sawa. So I want you to take some time, read these questions. If you're unable to understand or answer any one of them, you can always ask me, but you can also refer to the answers that are provided just below these questions in your notes. Asanteni sana.